Welcome to CES 2016, and welcome to our keynote, Beyond Smart Cities, the Future of Urban Mobility. You know, we have top leaders with us today who will share their visions on smart cities and mobility. Our panelists are stellar. They include the U.S. Secretary of Transportation, who reports to President Obama, and executives from Bosch, Qualcomm, Mobileye, and MIT to discuss the next wave of urban transportation and how technology is changing mobility in urban areas. This session will focus on possibilities in the near future, including autonomous cars, buses, and on-demand shuttles. As cars become more connected, technology will actually solve the biggest urban transportation problems. So I would like to introduce our panel. Dr. Volkmar Denner has been CEO and CTO of leading technology and services provider Robert Bosch since 2012. He oversees the $65 billion global company's 4 business sectors: mobility solutions, industrial technology, consumer goods, and energy and building technology. He's a member of several prominent boards and holds a PhD in physics from the University of Stuttgart. Welcome. Okay. Our next panelist is a delight. Secretary Anthony Foxx joined the U.S. Department of Transportation after serving as mayor of Charlotte, North Carolina from 2009 to 2013. Secretary Foxx recently launched the Smart City Challenge, a competition to enable mid-sized American cities to apply for federal resources which will be used to show what is possible when technology is used to address transportation challenges. The winning city will actually be awarded up to $40 million to implement bold, data-driven ideas by making transportation safer, easier, and more reliable. The Secretary has also pledged to issue a rule requiring the use of vehicle-to-vehicle communication technology by the end of 2016. Welcome, Secretary Foxx. Thank you. Good to see you, man. Our next panelist, Steve Mollenkopf, is CEO of Qualcomm and also serves on the company board of directors. He began his Qualcomm career as an engineer and for more than 20 years has helped define and implement Qualcomm's strategy and technologies that propelled smartphones into the mainstream. Prior to his role as CEO, Mollenkopf served as president and COO of Qualcomm. Please join me in welcoming Steve Mollenkopf. Okay. Welcome, Steve. And Professor Amnon Shashua, co-founder, CTO, and chairman of Mobileye, co-founded the company in 1999. Today, roughly 10 million cars rely on Mobileye's autonomous technology to make their vehicles safer to drive. In August 2014, Mobileye claimed the title for the largest Israeli IPO ever by raising $1 billion. Professor Shashua holds the Sachs Chair in the Computer Science at the Hebrew University of Jerusalem. Please welcome Professor Shashua. And our moderator, Kent Larson, directs the Changing Places Research Group of the MIT Media Lab. He's also director of the MIT House Research Consortium and the MIT Living Labs Initiative in the School of Architecture and Planning. Before his work at MIT, Larson practiced architecture for 15 years in New York City. Please welcome our moderator and all our panelists. Break away. Thank you.
So good morning. I'd like to start with Secretary Foxx. You have recently announced a Smart Cities Challenge, but this is not a typical funding mechanism from the federal government. You're not delineating deliverables for the cities. You're asking for creative new ideas. You're challenging the cities to think out of the box, to propose things that you haven't thought about, I hope. Why are you approaching it this way?
Well, what we recognize at the United States Department of Transportation is that we are at a moment where the convergence of technology and transportation offers enormous opportunities for communities all across the country and the world. But to realize those opportunities, the decision makers at the local level have to begin imagining how these tools can help them enhance mobility, reduce climate change, improve livability, affect their land use decisions, and help increase safety. And we have precious few mechanisms that actually urge that conversation as opposed to allowing it to happen at a much more slow and incremental level. So the Smart City Challenge is really about issuing a broad challenge to American cities and regions to say, if you've got a bold idea about how to move your community better, how to reduce the impacts on climate change better, how to increase safety better using technology, we're going to look at all of the various applications from around the country, and we're going to award one city $40 million. We're also very excited that we are bringing partners to the table. One of our early partners was Vulcan, which has put a $10 million amount of money on top of the $40 million we're offering. And today, I'm very pleased to announce that Mobileye is joining us in this partnership. Thank you very much, Mobileye. They have agreed to install their Mobileye Shield Plus technology on every single transit bus of the winning city. That's a big deal.
That's great. Well, Amnon, maybe you can tell us a little bit why you're involved in this program and what you intend to do in partnership with the winner.
Well, good morning, everyone. We are involved in developing technologies that avoid collisions. So it's natural to take that kind of technology into the city, where you have pedestrians and cyclists and people who drive motorcycles that are vulnerable, especially when you have large trucks. And what we built there is something that has two components. One is a kind of an obvious component, which is give an alert before a collision when somebody enters into your blind spot. That's an obvious. The second component is a bit smart, is to use big data in order to send all the alerts and near alerts back to the cloud, build a map showing where all the alert spots happened, and give that as a tool to designers and planners of infrastructure to see what kind of changes of infrastructure you can do in order to reduce collisions in the future. I think this is the more interesting part of this initiative, how to better plan the infrastructure based on real data, not just based on design or pre-thinking about what could happen, but actual real data. And we are very excited about that. For us, this is something new, all this big data, which is used to post-analyze accidents, and we are really excited to be part of this initiative.
So you're saying that you think there's a potential to have an impact on the design of the infrastructure of the city and even urban planning.
Exactly.
Which I think is quite exciting. Cities can be interesting living laboratories. Cities don't have any money, though. How does a big international company like a Bosch or a Qualcomm deal with this issue of lack of resources of cities, but this tremendous need for applying all of this amazing new capabilities to solve problems for people? Maybe start.
Well, we from the Bosch side, we work with a number of cities on pilot projects, one also in the United States. So I think around the globe currently there is a lot of interest in future smart city solutions, but so far I'm not aware of any decision really to implement it, and it's also a question of funding and of the right business model. I'll give you an example beyond mobility. In street lamps, for example, we currently see a technological change from the old discharge light bulb to LEDs, which saves energy, of course. So it makes a lot of sense to do this technological change. Now, I think it would be a missed chance if we substitute a stupid old lamp by a stupid modern lamp. Yeah. It would make a lot of more sense to think about, can we add additional sensors, for example, to such a lamp in order to offer additional use cases. For example, if we added sensors to detect the presence of people, we could automatically switch down the lamp when there is nobody around. We could add sensors that detects cars, for example. So in this case, lamps could serve to optimize traffic flow. So in this case, a lamp is much more than giving light. but somebody has to pay for it. So that's the problem.
Well, so if Bosch puts in such a fixture and a Tesla using Mobileye systems takes advantage of that, who pays for it? How does the money flow? Do you guys have any? I mean, I think it's a fundamental issue that cities are grappling with and companies are grappling with.
But it means we have to work on these pilot projects in order to find business models of the future.
Steve, you have any thoughts on that?
Well, from our side, I think we tend to come at it from the perspective of a general technology supplier. So we look at this as maybe it's an infrastructure problem. And one of the key themes is if everything's going to be connected, what network is going to connect everything? Who's going to buy that network? Who's going to provide that network? And it's different in the case of a city because it may not be a private entity, or there may be a significant spectrum issue that needs to be solved at a particular time. So they become less technical problems and they become public policy problems. And one of the key issues, and the Secretary and I were talking about this backstage, is you can have a technical solution, but because this is a new problem for a city, they don't have an office authorized to make a decision related to it. And I think that the municipalities that can lead in there will actually be exporters of a solution because everyone wants to do the same thing. Now, for our side, we believe kind of two things. One is that everything needs to be connected, so you have an ability to be a much better run city if you can have everything connected, but you can't have a situation where if the connectivity is not there, the city doesn't function. So you need smart intelligence on the device, but if you have it, then you can share that information. So the net result is when everything has connectivity and is being used for mission critical things like where it shows up in space and time, the amount of spectrum and the amount of connectivity will go up dramatically because everything is consuming bandwidth. That is a big problem that requires a tremendous amount of coordination to solve it. And it's a highly complex problem, but it is actually the challenge of the next half a decade, really, to get that right.
Should all urban data be open and accessible to anyone who needs it?
You know, the first step is to make sure that everything can share data, that everything has access to data, and that's one of the harder spots. I mean, lamp posts, street lights. We're going to go through this once in a city that's lifetime modernization. We should make sure that we have connectivity and everything as we do that because they're going to be installed for 40 years. Yep. So we might as well make sure that happens, and that's what cities are trying to do, and leadership from the Secretary and others making sure that we get that right on the front side.
So, Secretary Foxx, you were a mayor.
Yeah.
Before you went to the federal government. I find that I like mayors.
I like you too.
But I like them because they're doers, they're problem solvers, they're less ideological than those politicians you tend to find at state and national levels. They're close to their constituents. They have to pick up the garbage and fix the potholes. And a friend of mine, Ben Barber, wrote a book, "If Mayors Ruled the World," and I think he's right in that a lot of the resources, a lot of the wealth is created in cities. It flows out of the city. Cities, mayors beg for having enough of that come back to do the things they know that need to get done. Is part of the motivation for the Smart Cities Challenge to empower mayors, give them resources to do these kind of engage in these creative activities?
Yes, it is, in fact.
And do you agree with my assessment of mayors?
Well, yes, I do actually, in the sense that mayors have to think practically about things. As is famously said, there's no Democratic or Republican pothole. If you're a mayor, you got to get the garbage picked up, you got to make sure the snow gets shoveled, et cetera. And so part of this challenge is really about giving communities a reason to think about the problems that have been outlined here of this amazing technological wave that we have in transportation on the one hand, and resource constraints on the other. I happen to think that if we had just said, let's have a smart city challenge, and there were no resources behind it, I think we would have a lot less interest in cities, because they know they have mobility challenges, they know they have congestion, they know they have growth coming over the next 20 or 30 years. They know about the problems. The challenge is having the resources and the plan to deal with those challenges. So I hope that what happens out of this is that we get not just one right answer by the winning city, but we start to see cities begin to envision a future in which technology and data become part of how they grow and how they grow smartly.
Okay. Well, let's talk about technology and vehicles just for a minute, because that's what the halls are filled with.
Good.
You can answer this any way you want, but let me come at it this way. Vehicles are increasingly electronic devices on wheels. Mm-hmm. Which industry is better positioned to make vehicles in the future? Companies from consumer electronics like the Apples or the Foxconns, or a car company like General Motors or Volkswagen? Bosch works with many of these companies. What do you think?
Well, as Bosch, we are in a tier 1 position. So I could make it very short and say I don't care, because I want to be supplier. So we work with all of them currently, and they are our customers, and
so you don't care.
I can live with this situation very comfortably.
So Amna, you've experienced both worlds and academia. The electronics industry, consumer electronics in particular, they're much more, let's say, adventurous, and the car companies are more conservative. There are pros and cons to that when you're thinking about vehicles in the future. Who do you think are best positioned?
I think it's a provocative question. I think 5 years ago it would have seemed out of place. I think the fact that electric vehicles have lowered the bar for producing cars, because you don't have to carry the legacy of engine design and powertrain that goes over about a century. Making electric cars is easier, and it seems like the future of the car is going to be electronics on wheels. So it begs the question, who is better suited to produce a car, the car industry or a consumer electronics company? What I think is that consumer electronics companies that are used to build products that are single board products and are imperfect. Now, it's amazing how much we consumers have been accustomed to imperfect products. Mm-hmm. You know, you buy a gadget, it doesn't work as designed, as advertised. You wait for a software update, then it works slightly better, and then after a year you replace it to the new version, and all of us are okay with it. But in the car industry, it's different, right? We're not tolerant to imperfection. When we buy a car, it has to work, and if it doesn't work well, we're very upset. So I think both players, the car industry and the consumer product companies, they need to evolve. The car players need to evolve towards content, computation, artificial intelligence, user interface. The consumer electronic companies need to evolve towards building multi-board products that can work without any imperfection for at least 5 years. I think for the car companies, this is a natural growth. For the consumer electronic companies, this is a change of DNA. So if you ask me on where I'll put my money, I'll put my money on the car industry.
Yeah. You've worked with Tesla. Are they a hybrid company, sort of in the middle?
I think even Tesla had a rough start. They had the issues with imperfections at the beginning, and it took them quite a long time until they reached perfection. I think people underestimate how difficult it is to build a car.
Yeah. Steve, do you care?
Well, I'd say we're of the opinion that it opens up a market to sell technology across different markets. So for example, the car industry is absorbing a lot of smartphone technology. It's no secret. It is a different supply chain. That supply chain is optimized for things that are you know, very similar to what was just mentioned. They're optimized for safety, longevity, you know, for just a different operating point. They need to have a different customer engagement. But the mix of technologies and the people who are supplying into them are now very similar because the technologies are being shared. And even though the car industry is a large industry, it's actually not that large from an electronics point of view. So, you know, for example, 100 million unit market worldwide may seem like a big number, but it's small in comparison to, let's say, the smartphone industry. Yeah. So there's tremendous scale that can be applied as those technologies, or can be leveraged as those technologies move over. And you're seeing that. I mean, we've been in the car industry for 10 years, and it was very much in the early days about getting a car connected so that it could meet a mandate because of safety or a government mandate. Then it became the car is connected so we can do some services. Now the overall, how you maintain a car, how you manage a car, the user experience, you know, how a car is actually driven by itself, is all related to the technologies that are coming from other areas. And it's a tremendous opportunity for companies, but the end consumer who delivers the product may be optimized for a different thing like safety than you might see in consumer electronics.
But I do not completely agree. I mean, sometimes I have the impression that now that companies like Google entered the field, suddenly a lot of people have the impression that autonomous driving is coming from them. But I want to remind you, that the largest European research project was Prometheus many, many years ago on autonomous driving. So people were driving autonomously at that time already. Many of the functions which you have in modern cars go back to this research program. And at that time, we called it driver assistance. And a lot of functions which we have today in our cars are of this nature. So there is no need to, let's say, wait for the IT industry to teach the car industry how to drive in an assistant, in an autonomous way.
From the U.S. government perspective, we have to be agnostics on this question. And, but we are not agnostic on the fact that the wave of technology that's coming into this sector has to be responded to in a time frame that allows the best of it to get into the marketplace as soon as possible. And so we are working through our agency on issues surrounding autonomous vehicles, for example, where we have regulations that require a human foot on a pedal. And so even self-parking cars can become problematic from that vantage point. And so we're looking at how to adjust our regulatory system so that we are putting the foundations in place for these technologies to take root and let the market decide how it evolves.
Well, let's talk about autonomous vehicles just for a minute. There are, well, I have heard over and over again that many of the car companies are saying 6-7 years from now, the technology will be ready to drive in all conditions. I don't know if you agree with that. I've also heard many people saying that well, they take two positions. One is we have to go to full autonomy because mixing humans and robots is very dangerous. Other people say, no, it has to progress in a logical, incremental way. When will we see full autonomy, and will we have, what happens in this transition period?
Well, I believe fully autonomous driving in the most complex environment that we know of in city driving condition is something we will not see in this decade. Okay. I think we might see it in the next decade.
In this decade.
But for me,
this is 2016. So.
Now, for me, it's something that currently I'm not able to predict when this will happen between 2020, 2030. maybe in this decade, but when exactly, I think it's not possible to predict this. But frankly speaking, for me, this is not the most relevant question. The question for me is how can we as engineers, as researchers, split this long path down into feasible next steps, each of them giving a high customer benefit. So for example, we can drive autonomously already today under two conditions basically. If speed is low and if we know the environment very well. Well, where are these two conditions met today? For parking. That's why autonomous parking will come very soon. As I showed in the video, we believe fully autonomous parking inside a parking garage without a driver in it, we will bring to the market 2018. And we are working very hard that this will happen. Next step will, of course, be highways, because on highways, traffic situation is much simpler than in the city. Therefore, the autonomous driving on highways, we split down also in different phases. The last one, where we drive from exit to exit fully autonomous, we want to achieve by 2020. So I think of this path in splitting it down in several parts. We have done this in the past already, for example, with predictive emergency braking. When we started this many years ago, the question was exactly the same. How can we arrive at a vehicle that brakes autonomously in terms of a dangerous situation? And the path that Bosch took at that time was we split it down in 3 phases just to be able to learn how to handle these complex situations. And I believe we should take the same path with autonomous driving as well.
Okay. No?
I believe that autonomous parking is exactly as Volkmar said. It's within reach, but it's not exciting. It's not transformative. It's not what we are all waiting for.
Yeah.
I think autonomous driving is exciting because it has the potential to transform transportation. And I believe that it's not that far away. Now, in order to understand what's going on with autonomous driving, there are 2 markets and 2 camps going there. 2 markets is that there is the normal buying a car, buying an option. That option is autopilot, automatic parking, highway autopilot, and so forth. And there's a limit of how much you can pay per an option. Therefore, the cost of sensing should be very, very low. Everything should be optimized. And it makes sense to go by stages. First, highway autopiloting, automatic parking, then increase that step by step until you reach to a level which you think is enough and people are willing to pay for. But the second market, and that's the more exciting market, is the shared mobility. So if we can have cars, Uber type, Lyft type of cars that drive and pick passengers but without a driver, the business case is very, very attractive. You take the driver out of the loop and you have cities swarmed by pods shuttling people back and forth. And this requires fully autonomous transportation. And this is where the excitement comes. The excitement doesn't come from enabling highway autopiloting. That's kind of a natural growth of where the automotive industry is. The excitement comes at the point where we can have cities driven automatically, autonomously. And the question is how to get there.
Well, there are people that believe that privately owned autonomous vehicles will kill cities. I've heard that said. It increases the number of trips. It allows for more sprawl because people can be productive going to and from work. You have many more vehicles on the road in many scenarios, whereas shared use autonomous vehicles have some amazing benefits because you can reduce the number of vehicles, much more efficient, essentially get rid of all parking. And there are people considering regulation that might prevent privately owned autonomous vehicles in cities. Is that kind of regulation, you think, in our future?
You know, there's an interesting set of debates across the country around Uber, actually around the world.
Yeah.
And I think it's one of the first waves of this debate. And you know, some of the rules around parking regulations are just inherently local rules. But when it comes to the deployment of a technology like autonomous cars, our department's mission, its fundamental mission, is to ensure that products that are in the marketplace are safe. And our goal as an agency is to step up the speed with which we can make those evaluations, because we don't want to be in a situation where a technology is presented to us, it takes us 4 years to evaluate it, and in the intervening 4 years, there are 2 generations of the same technology that have gone past the original submission. So we have to move faster, and we realize that, and that's what our commitment is. I think at the state and local levels, there's still going to be areas where some of this is going to have to be sorted out, and I wouldn't suggest changing it and federalizing parking regulations,
That's right.
if that's the question.
But maybe through your Smart Cities Challenge, some of these issues could be explored.
I think that's exactly right, and that's really the point, is that you know, local communities, quite frankly, are going to have to put meat on the bones of what smart cities really means. That's a phrase that's been used a lot. I think it means different things in different places. But in the U.S., what we want to do through this challenge is to actualize what that means, to start creating not only an image of what it means, but an actual city that is defining that in practice.
But can I ask a question? Secretary, could you imagine that the legislation follows our technology development? Because, as I'm sure you know, in many parts of the world, we have the Vienna Convention, which the US did not sign, which prohibits at the moment that we drive fully autonomously. It's changing at the moment into our direction. And I've just recently read that in the US also there is a draft for regulation saying the driver must be able to control the system, which means things like autonomous parking would not be possible because there will be no driver inside. So what my request would be, yes, what we do in terms of autonomous driving has to be safe and reliable, no question, that's our engineering task, but we need the support from that legislation that as soon as we are ready, legislation is changed accordingly.
Yeah, one of the things we've done is we've actually reached out to a number of technology companies to ask them where in U.S. regulation there are impediments to autonomous vehicles. And we are actually in the midst of reviewing some of what we've gotten back as a result of that. We're happy to have your folks reach out to us as well. But you know, we can't compromise safety, but we also recognize that connected cars and autonomous cars also have a lot of promise to increase safety. So we want to make sure we're doing the best we can there. And I can't speak for Congress, but I can tell you that from an administration standpoint, we're going to do everything we can to set the dial correctly for the future.
Yeah. Steve, you have any thoughts on regulation and how that might impact what you all are doing?
Well, I think there's a reason why planes are connected to themselves, and their air traffic control systems, and you know,
Yep.
it's a better way to do it. I think that is a key component to increasing safety.
Yep.
And but you know, as you said in an earlier question, you need to be able to operate the system without that being there. Mm-hmm. And those type of regulations, infrastructure-wide regulation, you need to make sure are not holding up the building of those type of systems. At least from our perspective, that is what the problem that we try to work on.
Let's go beyond the vehicle for a minute and just talk about how things are changing with respect to connectivity and intelligence. I mean, we're getting to the point where computation and sensing is essentially free, at least compared to what it was 10 years ago. And it is entering into almost everything man-made, from cars to our homes. I know Bosch and Qualcomm are both in both spaces. How do you see the car and the home and other environments being connected in a more seamless way? And if you could address this follow-up. Much of what I see out there in the hall is dealing with, I think, low-hanging fruit, like increasing efficiency, making energy a little more efficient, or increasing a little bit the throughput of vehicles on the highway. But how can we use this amazing technology for applications that are game-changing, that can really improve people's lives in a fundamental way, make society more creative, or allow people to live longer, et cetera? How is your company thinking about that?
What we show here in our show car in the North Hall is an example of this. We see the car of the future more like a personal assistant, I would say, or some people might say it's a kind of third living space after office and home. Inside the car is a third living space. But I'd like to look at it in this way as a personal assistant, which means it has to be much smarter, much more human-like than today. So, for example, the car of the future must be able to learn. Today, it's not learning. And it has to interact with the rest of our lives. So, for example, what we show in this show car on our booth is a car that interacts with your smart home. So when you approach home, of course, you influence, for example, the heating system so that the temperature is comfortable, or you might have a look at your video cameras of your security system at home and check that everything is safe before you leave the vehicle. Things like this, for me, is a connected car of the future.
Okay. How's Qualcomm?
We have almost the identical view. I mean,
Sorry?
We have almost the identical view.
Okay.
It becomes more of a personal assistant, and it also it's almost a combination of a personal assistant, and then it senses so much information about the environment that if you have that information across the entire population of vehicles, it's very powerful to be able to manage the city. Or people have been building low Earth orbit satellites to spy on the to spy on the world, weather systems, what have you. The car has much better information if it can be shared, and from safety or a lot of things. And so it benefits the individual operator of the vehicle, but it also benefits society as well.
I guess what I'm looking for are game changers, things that are more disruptive.
Yeah, I completely agree, but it's important to notice that the car is a perfect platform for artificial intelligence.
Yep.
We have sensors that scan the visual field, and we have computers that interpret the sensing and understand what's going on in the visual field. And then we have also artificial intelligence to understand how to plan the movement and strategize how to merge into traffic. All the things that we know are difficult for humans because we take many driving lessons until we learn how to merge into traffic. So there's sensing, there's visual interpretation, there's intelligence, and we can. Then there is mapping, connectivity, and mapping, and we can combine all of that and get autonomous cars. But we can do more. And if you have sensing, the sensors can understand what's going on in the world. And if we resolve some privacy issues here, we can collect a lot of data, big data, analyze it exactly as you said, and that could be a game changer. You have all these millions of eyes always looking, scouting around, understanding what's going on, and providing information. So it sounds like a big brother thing, but if we resolve the privacy and big brother concerns, it could be a game changing of what we can do with this kind of information.
We also believe that if you layer on also where the people are, so people are carrying a phone or they have some device, there's a tremendous ability to improve, it's one more dimension to the big data problem.
I want to talk about data for a second, because I think data itself can be a game changer from a regional and a city perspective. Just to use an analogy, I got one of these trackers for my diet and steps and things, and I plug in something I eat thinking that the calorie input is one level, and then I look at it, I find out it's much higher than I thought it was. I think that's programmed into the way we think about transportation and mobility too. I think when we think about building a new road, we believe that it's going to create more throughput and give us better access, but data may tell us something different. When people are deciding to take a trip, whether they're going to walk or get in a car. Data can tell you that there's a traffic jam. It's going to take you 20 minutes to get where you're going. If you walked, it might take 10 minutes. So I think that data is going to help almost create a renaissance in the way that cities begin to plan. And I think that what we can expect, hopefully over the next 20 or 30 years, is a much better idea of what's actually going to get us from one place to another faster, and a broader set of choices that people have in communities, whether it's walking, biking, cars, trains, commuter rail, transit, whatever it is, that's going to give a community a system of transportation that's fluid enough to give people choices to move around more efficiently.
I would fully support this. One example we are working on in this pilot city project is intermodal transport, because that's existing today as well, but it's very cumbersome for an individual to change the transport system, and it's not transparent. So that's the reason why the people stay in their car and stay in the traffic jam, because it's not evident whether you have a choice. But with modern technology, with connected vehicles, we have this choice. So we can build really solutions where it's evident if you want to go from A to B, what are your options? And you can book it with one app. This should be the intermodal concept of the future, I think.
So we've talked a lot about personal mobility, but there's this whole world of mass transit, which is changing very rapidly. And there's also the challenge of moving goods. Packages are clogging. You know, the delivery trucks are clogging streets. How do you see these new technologies solving problems with respect to mass transit and the logistics of moving goods? Are you working in that area?
Well, you're right. I think this is one really very, very big challenge, because the purchasing behavior of all of us is changing constantly towards purchasing via the internet, which means we have all these parcel services in a highly inefficient way, delivering these parcels to our homes that really cries for some improvement. Yeah. We need some improvement there. I don't have the solution yet.
Do you have the solution, Steve?
Well, I think the issue with goods is you can add the Z dimension. So you can go up much easier. People will accept it more. Of course, people are using drones as a way to do that. And I think that's maybe a perfect example of what I was trying to say earlier, which is that the drone industry, the reason that it's cheap and can be easily done is it's so highly leveraged from another industry, which tends to be the one that we come from. And so it's very easy for people to experiment at a price point and actually a size that enables those things to occur. But the issues are very similar in the sense that it's a safety issue, it's a major coordination issue, there's a human issue, which will they accept these type of things occurring?
Can you see 1,000 drones at any given moment in Manhattan?
Well, I think you could, but it'd be much easier to do it than to get people to accept it, is the point I'm trying to make at the beginning. And the problem will be maybe not an engineering problem, it'll be a problem in psychology that people need to figure out.
So what are the biggest barriers to the adoption of these new amazing systems? There's technical barriers, regulatory barriers, standards, just human acceptance and values. What's top of your list?
Well, just very quickly, I think it's difficult to experiment on some of these things because the regulatory environment is, in many cases, rightfully, it's difficult to experiment on things that can hurt people. Yeah. Right? So you need to find some way in order to prove that these techniques are going to be difficult, and that there are certain places where it's easier to do that than others. And I think you'll see regions take leadership positions because it is easier for them to experiment in certain areas.
And thus the Smart Cities Challenge. What do you think are the greatest barriers?
I think it's important to manage expectations. I think autonomous cars are not going to emerge one day and take over all driving. They will drive among us, right? And these vehicles will have to drive like us. They'll have to adopt human driving behavior. I'm not talking about drunk driving behavior, but human driving behavior, because without it, we will not tolerate vehicles that drive too slowly and hesitantly, and we have to overtake them all the time. So they have to adopt human type of behavior, and this means that we cannot expect zero accidents by robotic cars. I think, and I think it's provocative, but it's important to discuss it. I think the best we can expect is that robotic cars will reduce the fatality rate by 2 or 3 orders of magnitude. So if today we have 35,000 deaths in the US, fatalities, if we reduce it to 100, 200, then we have done a big service to society. Those 100 or 200 fatalities will be because of the robotic system, but then society will learn how to deal with it. This, I think, should be on the table. We cannot expect zero accidents, because then these cars would never drive. And, and we see this also in the media, all sorts of jokes about the experimental cars, autonomous cars, driving very slowly and very hesitantly and so forth. And there's technology to do that. There is real technology to learn behaviors, multi-agent games, and the industry should look into it, but it's important to manage expectations.
We have 10 seconds left. Would you like to have the final word, because everyone else had a chance to address that issue, what the greatest barriers are and challenges?
Yeah, sure. Well, we believe from the Bosch side that the future of mobility, as shown in the video, will be electrified, automated, and connected. We talked a lot about automated cars, also connected vehicles. I'd like to therefore make a final point on electrified cars. If we say electrified, it doesn't necessarily mean it has no internal combustion engine, but maybe it's a plug-in hybrid. But I think in urban driving conditions, we need a concept based on electrical propulsion concepts that creates zero emissions, and also, and this is sometimes neglected, is much lower in noise, which is very relevant in cities.
Well, thank you all. I had many more questions, but I think we got through the highlights. So round of applause for our panelists.